Hey guys, today we're going to graph polynomial functions. And as you know, anytime we do any graphing, we'll need our calculator. You will also have some time to practice on your own and then come back and check your answers. So a polynomial function, yeah, I know this looks really complicated. We've talked about what polynomial function looks like. We've talked about what leading coefficients look like. We've talked about what degrees are. So in this case, our degree would be n, and our a sub n would be our leading coefficient because the highest degree and the leading coefficient go together. So what we're going to look at here is we're going to do some degrees and some leading coefficients real quick. F of x equals 4 is our constant with a degree of 0 and a leading coefficient of itself. 5x plus 1 is a linear function, degree of 1, leading coefficient of -5. And before I go any further, there is a chart, just want to make sure you know, on the first section on polynomials that is not in the video, but it's information you need to make sure you need to know. Like, for example, if I wanted you to name this function, you would need to know that that is a quadratic, because of the three terms trinomial. So this would be a quadratic trinomial. The information in that chart will show you how to name polynomials. Degree is the exponent 2, leading coefficient is 12, 3 and -1, 4 and -3, 5 and 9. And now we're going to do some polynomial parent functions. We have done these, and so this should all be a review. A constant is just f of x equals a number we'll call c. It has a horizontal line. Linear, f of x equals x. It is your diagonal line through the origin and through quadrants 1 and 3. Quadratic, f of x is x squared, is your upward facing parabola that goes through your origin. It is a curve, not a point. And a cubic function, f of x equals x cubed, goes through the origin, points 1, 1, and -1, -1, and it is a curve. Pause your video if you need to catch up. A quartic function is going to touch the x-axis at most 4 times. F of x equals x to the 4th. And it typically looks like a parabola, but the bottom is a little bit flatter because it does cross so many times there in the middle. And then a quintic function, f of x equals x to the 5th. Let's see what that looks like in our calculator. This looks actually very similar to a cubic function, but it's going to cross quite a bit of times too. So we're just going to kind of flatten that out to go like that. Now we're going to use our graphing calculator, and we're going to graph each of these functions, and we're going to do our end behavior. I'm going to do the first 2, and you guys are going to do the last 4. So 4x to the 4th plus 6x to the 3rd minus x. So as x approaches infinity, f of x is going up to infinity, and as x approaches negative infinity, it's also going up to infinity. Problem number 2, negative x squared plus x. We've done end behavior so much that this should be all review for you. As x approaches infinity, see how it goes down in both directions? So it's going to go down in both directions here. All right, guys, if you will take a second and pause your video and work 3 through 6 and then come right back. All right, let's see what you got. And if you have questions, please make sure you let me know. Number 3, as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. Number 4, as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches infinity. And number 5, as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. And number 6, as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches negative infinity. So now what we're going to look at is this little chart on how we can use whether a function is even or odd and whether it has a positive or negative leading coefficient to choose our end behavior. So if it has a positive leading coefficient and an even degree, the end behavior is up and up. Positive leading coefficient and an odd degree is down and up. So infinity, negative infinity. Negative leading coefficient, even degree, both are negative infinity. Negative leading coefficient, odd degree, is positive and negative. And we're going to look at that for here for problem number 7. So first we have to decide, is it even or odd? Well, it crosses 4 times, so it's even. It has negative infinity and negative infinity, so it's going down and down. So according to our chart, the leading coefficient is negative. Number 8 crosses 3 times. It is odd. In behavior is one of each, but you got to make sure you look and see where it is. So the leading coefficient, negative, positive, is positive. All right, now we're going to look at turning points. A turning point happens when your graph changes direction. So if the turning point is higher than any nearby point, it is a relative maximum. If it is lower, it is a relative minimum. That should make sense, I hope. If not, let me know. And any maximum and minimums are called extrema. And turning points decide on your graph where you're increasing and decreasing. You are going to need your calculator for this next one. We're going to graph the function x cubed minus 6x squared plus 7x plus 2. We're going to use our calculator commands to find our minimums and where we're increasing and decreasing. So we're going to start here with this maximum. So second trace 4. And it prompts you to what you need to do to find this maximum. Left bound means you need to be left of the maximum. I am currently left of the maximum, so I hit enter. Then it tells me to go right of the maximum, and you can go anywhere right of that maximum and hit enter and enter. And we're just going to round. 0.71, 4.30. Now we're going to do the same thing for the minimum, but we're going to choose the minimum option. So second trace 3, I need to be left of the minimum, hit enter. I need to be right of the minimum, hit enter, enter. And I get 3.29, negative 4.30. So where are you increasing? You're increasing anywhere as you read your graph from left to right that you're going up. So we're increasing from negative infinity to our maximum point, which is 0.71. So negative infinity to 0.71, and then we're decreasing from the x coordinate of the maximum to the minimum, so 0.71 to 3.29, and then we're increasing again from 3.29 to infinity. So we're going to have some more practice with that here in the next couple sets of problems. So go ahead and clear your calculator, and we're going to graph the next problem, negative x to the third plus 3x squared. We're going to put the graph on our paper, and we're going to list all the characteristics here. So I'm going to use, I see 0, 0 is one of my points, but I'm going to use my table to make sure my points are pretty clear. So negative 1, 4, 1, 2, 2, 4, 3, 0, and then 4, negative 16 is too far. So I'm going to follow my graph, connect my dots as best I can. Take this little side part out here so I can get the white out to work. There it goes. And as you can see, there are no restrictions on the domain and range. Domain is going to cover all x's. Range is going to cover all y's. We're going to use our calculator again to find our maximum and minimum values. So I'm going to do my minimum first, second trace 3, left, right, and enter. And it's at 0, 0. That -6 and -11 lets you know that it's scientific notation with 6 zeros and 11 zeros. It's 0, 0. Make sure you put it in the right place. Maximum second trace 4, left, right, and enter 2, 4. And as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches infinity. You are increasing between the minimum and maximum, so from 0 to 2. And you are decreasing from negative infinity to 0 and from 2 to infinity. Just remember, you're reading your graph from left to right. Where it goes up has a positive slope, it's increasing. Where it goes down with a negative slope, it is decreasing. We're going to do number 2 together, and then I'm going to let you guys work on 3 and 4. So graph. We're going to put the graph on the paper, and you are welcome to analyze the graph on your calculator to find all your pieces if you'd like. Before you graph on your paper, just don't forget to do that. We know 0, 5 is a y-intercept. And then I'm going to use my table to find some other points. So -2, -3, -1, 1, 0, 5, 1, 3, and then 213 is going to be way up there. And let me look one more time. All right. This is going to be my minimum point. And I saw that on my graph, so I'm going to go ahead and put that on here. -2, -3. And then according to my graph, 1, 3 is also a minimum point. And my maximum point was 0, 5. So I was able to look at my graph points, look at my graph, and find these without using all of those other commands. So we have a minimum and a maximum and a minimum. Rough sketch here. Domain has no restrictions, but because range has a lowest point and it's included in that point, it's everything above that. So we put a bracket, -3 to infinity. As x approaches infinity, both of these go up to infinity. So as x approaches infinity and x approaches negative infinity, your graph goes up. Now, where are you increasing? Remember, read from left to right. So you're decreasing first, then you're increasing, then you're decreasing, and then you're increasing again. As you read your increasing and decreasing intervals, they should flow. So negative infinity to -2, -2 to 0, 0 to 1, and 1 to infinity. All right, you guys are going to need to do some rounding, so you're going to need to be finding your maximums and minimums using your commands for problems 3 and 4. If you will take just a minute and pause your video, and then come right back and check your answers. All right, problem number 3, here's your graph. Domain negative infinity to infinity, range negative infinity to 6.5 with a bracket. Relative max, negative 1.57 to 6.5, and 1.16, negative 1.91. Relative minimum, 0.41, negative 2.59. Those are ordered pairs, not intervals. As x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. You are increasing from negative infinity to negative 1.57 and from 0.41 to 1.16. You are decreasing from negative 1.57 to 0.41 and 0.41 to infinity. Number 4, your domain is negative infinity to infinity, range negative infinity to infinity. Relative max, negative 0.12 to, negative 0.12.06. Relative min, 1.45, negative 3.76. in behavior as x approaches infinity, f of x approaches infinity, as x approaches negative infinity, f of x approaches negative infinity, and increasing from negative infinity to negative 0.12 and from 1.45 to infinity, decreasing from negative 0.12 to 1.45. One correction that I see needs to be made, this should say 1.16. You are decreasing from 1.16 to infinity. All right, guys, this concludes our section on graphing. We will look at zeros and multiplicity next. Let me know if you have any questions, and have a good day.